Hi and welcome to another video. Today we are talking about proof of work and proof of stake. If you don't know anything about those two concepts, never heard of them, I recommend you watch my blockchain video first because those two concepts are closely correlated to the blockchain and it's good to know a little bit about the blockchain. If you have already heard of those two concepts or have watched my video, we're starting now. So we're starting by talking about proof of work. Proof of work basically means that a user has to do work before using a system or an application. So it's a method that ensures that a user did some work and then after that can use a system. Why would you have to do some work before using a system? Well, in the 1990s, when the internet was coming to popularity, emails were a big concern because of spam. And then some intelligent guys invented proof of work to counteract the spam, because if you have to do some work before sending an email, as a user it doesn't matter because it was like 1 or 2 seconds delay. But if you're sending millions or thousands of spam emails after another, then the delay was hard and was annoying. So that's why they invented proof of work. And proof of work today was basically made popular by Bitcoin. So if you have heard of proof of work, you probably have heard of it in some form or another with cryptocurrency or Bitcoin. Okay, so now we are talking about proof of work in the concept of blockchain, or the proof of work concept in the blockchain. So inside of the blockchain, the miners have to guess a pseudo-random number. It's called nonce. It was short for number used once. So these miners have to guess a number, and this number is combined with the block hash. So a block is created on the blockchain. The content of the block, or the block itself, is hashed. So it's creating a hash out of this block. And this is combined with the nonce, creating another hash. And this hash is what they have to guess. And this hash is always the same size. So no matter what the size of the content, the number, anything, the hash is always the same length. And the condition for this hash, because now you can just pick any number and combine it with the block hash and then you have another hash. It's no problem. But the difficulty is you have to guess a hash with a specific number of leading zeros. So there have to be zeros at the beginning of the hash, and depending on how many zeros the hash has to have at the beginning, the harder it gets. So the more zeros, the harder it is to guess the right number to create this hash. And the difficulty of the hash, so the difficulty that is used to generate or to set the number of leading zeros, is depending on the computing power of all miners. Because Bitcoin wants to make sure that once every 10 minutes a block can be mined. And if there are too many miners, or if there is too much computing power, then the blockchain, or the Bitcoin blockchain, just says, the algorithm behind it says, okay, we are creating too much blocks in a too short amount of time. We have to make it harder. So they say we have to have more leading zeros. And that's how they adjust that every 10 minutes, or around every 10 minutes, a new block is mined. So now if you are a miner and you give your computing power to this blockchain, you want something in return. And blockchains, or Bitcoin, is doing this by rewarding miners with Bitcoin, or their cryptocurrency, just so they can use their computing power and therefore they get the cryptocurrency. And if you want to attack the blockchain and alter the blockchain, you have to have 51% of the total computing power of the blockchain. That's why it's good if you have more miners on the blockchain, because the more miners there are on the blockchain and giving computing power, the more power is needed to alter the blockchain. And that's why the miners also are rewarded, because in this way they can ensure that there are miners keeping the blockchain running. And actually this 51% attack is called 51% attack because, yeah, you need 51% to attack the blockchain and alter blocks. And also a security feature of the proof of work algorithm or the blockchain is the hashing of the individual blocks, because if the blocks are hashed, you can't alter the block without changing the hash. So the hash is a combination of everything, of every metadata included in the block, of the content and the nonce. And this hash gets changed as soon as you change the block or the block contents. And in that case, it's ensured that if there is another hash, the miners have to validate the block again, but they see, this hash has been changed, so it's wrong, and the block just gets destroyed. So the false block, actually. Okay, so now you know how the proof of work method or algorithm or concept works. And actually there is another one. As I said before, there is the proof of stake. Proof of stake isn't as old as proof of work because it was mainly introduced to reduce energy consumption. Because with the increasing popularity of cryptocurrency, people have noticed, damn, this thing takes increasing amounts of energy and computing power. And with climate change and all of that, it gets a major problem. So they introduced proof of stake. Proof of stake is a different concept because in this concept, users have stakes or tokens depending on the amount of coins they have. So for example, in Ethereum, if you have 100 Ethereum, you have more stake in this cryptocurrency than a guy that has 1 Ethereum coin. So you, as with 100 Ethereum, have a higher stake and a higher validity to this blockchain. And then there is an algorithm that is choosing users to validate and mine the blocks randomly. But it's not completely random because, it kind of is, because depending on the amount of, depending on the stake you have, you can think of it as a lottery ticket. So for 1 Ethereum coin, you get 1 lottery ticket. And the more tickets you have, the higher are your chances of getting chosen. So if you have a lot of coins or tickets, you have a high possibility to get chosen to validate and mine the block. And there are multiple users that are mining and validating, and therefore it is also secure, but not as energy and computing power intensive as the proof of work algorithm, because you don't need as many people to validate. You only need a few, but you know these people are good and they want to ensure that the blockchain is running and don't want any harm because they have such a high stake inside or into this cryptocurrency. And yeah, here it's again laid out. The more coins you have, the higher is your stake and the higher is your chance to be a validator. Just because you have more tickets or more lottery tickets, so you have a higher chance to be a validator. Then for Ethereum, there is a minimum limit to be a validator, which is 32 Ethereum. So if you have less than, you can also participate mostly in mining pools, but if you have 32 or above, you can be considered a validator. And they set this limit because they thought, okay, if you have 32 Ethereum, you are considered a person with a high interest in this cryptocurrency and in this blockchain, and you probably don't want any harm to this blockchain. And yeah, the thing is that this concept, proof of stake, is not dependent on resources. So it's not depending on time and computing power, which makes it having a low chance for 51% attacks. Because it doesn't matter if you have 51% of the computing power, because there is no computing power needed actually. That's why there basically is almost no chance for this attack. But there are other attacks that you can do, and the other attacks get punished on Ethereum blockchains, for example, or on proof of stake blockchains. So if you try to alter the blockchain and you get caught, you lose your coins, which is the punishment for trying to alter the blockchain. And for example, what you can do is you can have a huge amount of Ethereum coins and just alter the last block. But if you get caught, you lose all your coins and you lose a lot of money. And that's why people mostly don't do it. That's what the security of the proof of stake algorithm is. Okay, and now we are done. So I hope you learned something new about the proof of work and proof of stake algorithms. They are different. They have both their upsides and both downsides. I'm not going into too much detail because it can be really difficult to understand the full concept, but the basics you now know, and the basics are the most important, I guess. If you want to know more about them, there are a lot of resources you can get in the internet which are talking about this in depth and talking about how the algorithm works, how everything in these concepts work. So yeah, if you enjoyed the video, consider leaving a like, and I hope you learned something new. If you have any questions, just ask in the comments, and see you in the next video. Bye!